So, good evening, everybody. Welcome to this evening's Audio Engineering Society webinar. I'm Neil Johnson, Chair of the UK section of the Audio Engineering Society. Before tonight's talk starts, I've just got a couple of housekeeping items to discuss. As you saw earlier, on the slide deck, we have some forthcoming talks on the UK section programme. Tonight, we have Geoff Hill talk about loudspeakers. Next month, May, is the European Convention in The Hague. That's both online and in person. And then in June, we have Casper Anderson from Roku talking about audio technology in televisions. During the talk, if you have any questions, please use the Q&A button at the bottom of the screen, preferably not the chat, so that we can put all the questions in one place, make sure we don't miss any. And then after this webinar, we will move to a Zoom meeting where anyone who wants to come along, and we encourage as many of you as possible, can have a chat with Geoff directly, one-to-one. Or in times past and times future, this will be akin to going to the bar for drinks and a chat afterwards. And just finally, waving the AES flag, if anyone in the audience tonight is not a member of the AES, please consider joining. We have a broad program of talks and events throughout the year across the world. We have a wonderful library and other great resources, and it's a great opportunity to network with our fellow audio engineering folks across the world, as is this talk goes out globally. So that's enough for me. I've done my 1-minute spiel, so allow me to hand the microphone over to my vice chair, Dr. Michael Turner, who is going to have a fireside chat with Geoff Hill. Thank you.
Thank you, Neil, and good evening, everyone from me. Just a point on the questions. If they do fit with the thread of the conversation, then we will attempt to address them as we're going along. So feel free to sort of type them in as you're going. As Neil says, please do use the Q&A, not the chat. And if I see a question coming up that sort of fits with where we're going, I'll try and fit it in. Otherwise, we can address those obviously in the informal discussion afterwards. It is an informal discussion tonight at Geoff's request. And as Neil was saying, whenever we're discussing AES membership and its benefits in committees and all the places that those things get discussed, networking is always a thing. It's certainly one of the reasons I joined the AES a long time ago, was to meet people who had made our industry what it is. And by that, of course, it's not just the producers and the musicians or the academics who write the papers, important as all of those are to us. It's also the guys who design the hardware and make the products and are behind a lot of the famous names. And that fits very well with Geoff's career path, as you'll no doubt hear this evening. Worked at Goodman's, B&W, Monitor Audio, to name but a few. Geoff, good evening. Welcome to the AES talk this evening. Thanks for joining us.
Good evening, Mike. And thank you, Neil.
I'm going to drop out of view most of the time because nobody needs to see me. But what I do have is some PowerPoint slides that are just to sort of illustrate the conversation as we go along. Hopefully those will be helpful rather than intrusive. If I do that and I do that, with a little bit of luck,
in PowerPoint, they're up full screen now.
Are we full screen and everybody can see that, I hope? That's good, okay. So Geoff, you've always been very much a member of the E in the Audio Engineering Society, and I know that's something dear to your heart, engineering for products and product design and so on.
Absolutely. It's a bit of a personal bugbear of mine. The engineer seems to have got lost a bit, you know, with, you know, everything from a recording engineer to you know, the guy who fixes a dishwasher in being called an engineer. And that always sits uneasily with me, shall we say.
Indeed, and you've not only been active in engineering, but also in sharing engineering, which I believe is also something that you're passionate about, and we'll come back to later.
Absolutely.
But you didn't start in audio, though. Tell us when and where the engineering career began.
Well, I did sort of start in audio. I was making speakers and stuff when I was at home, and I was knee-high to a duck. But formally, I was trained in electronics, a company called Allen West in Brighton. So I got my, formal qualifications there.
Very famous manufacturer of switchgear, of course, to those who don't know them, contactors, relays, timers, all that sort of thing. But school, the audio bug bit early then at school.
Oh yeah. We had a chemistry master who had brought in an old turntable. I think it was a Rock or something like that he was going to strip down for the bearing. And Dad had a workshop, and so I volunteered with Dad to produce a bearing for a turntable for him, and in return I got a first record player, and it was downhill from there on in.
Yes, indeed, and you I think most of us, or many of us, will identify with that route into hardware. And you mentioned you'd already been, when you were at Allen West, you were already collaborating with Brian Taylor.
Yeah, I'd met him a few years before, because I'd got an interest in all things audio, and he was out in Worthing, not far from where my parents lived, and he wanted to do stuff but hadn't really got going, and eventually he did, and we joined up and started to do some stuff in the background whilst I was working for Allen West as a test engineer. And then when Allen West came to an end, I went full time, decided, right, it's made redundant, right, okay, what do I want to do? Do I really want to do electronics and DC motor drives, as it was at the time? And the answer was no, not really. So I moved sideways into that. The H3 and then the H2 and the H2A were the first designs that I worked on with Brian, and I was intimately involved with both of those. So not quite at the very beginning of it, but pretty early on.
And these would be horn loaded designs primarily.
Yes, yeah, horn loaded designs,
and therefore presumably very efficient. I know that's
well, that was the aim of it. Yes, the truth is that they weren't as good as they, perhaps could have or should have been. But I was, wet behind the ears, and we didn't have the equipment or the facilities to do the job properly. Plus, an anechoic chamber, which at that time was de rigueur, was way beyond what we had the capability of doing. And it took some time to get to the point of working out how to solve those sort of problems, which we'll come to later.
Yes, indeed, and at that point, or not at that time, when you were working with Brian at Impulse Loudspeakers, I don't know whether Brian's with us this evening, but a nod to him if he is by chance. Now with a company called Aspara, I think. You saw an advertisement which led you elsewhere.
Yes, to B&W at the Stenning Research establishment, where I was an electronics test engineer, working on the Active One, the MPA 810 amplifiers, and the preamplifier that you can see there. So I was using the Tektronix 500 series analyzer and stuff, and an anechoic chamber for doing the measurements. So it was the first time I really came across an anechoic chamber, and but I was primarily employed on the electronic side. And it was one of those, you know, typical situations that I went along for an interview, and the guy who was interviewing me, Greg, was saying, well, you know, we've done this and we do that and we do that and we need to do this and we need to find a component level, and he just kept on going on about fault find component level, and I thought, what the hell's going on? And then I looked around whilst he's doing this, whilst he said the same thing about half a dozen times. I'm sort of saying, scratching my head, saying, what's going on? And glancing around, I can see on to the wall there's a posters which has got the circuit diagrams of the filters and an amplifier and whatever. So I'm surreptitiously looking over that, because I was at that time, you know, moonlighting partly in music shops doing repairs on amplifiers and stuff. So I was quite used to fault finding stuff on the fly without any circuit diagrams. So, you know, I eyeball anything and just try to find out what's going on just for pure interest's sake. And he kept on going on about this. Funny. And he's, you know, he said, well, he come from the post office and this, that, you know, and he's going on about this. And I said, look, hang on a moment, Greg, you know, I could see all these little green bins and there's loads of boards on there sticking up, and there's a few of them to one side which got green stickers on, there's other ones there and a load of them with red stickers. I thought, okay, all right, he doesn't know how to fix these things, does he? So I said, look, okay, Greg, look, you've got a load of the boards there. I'm reckoning one or two of them aren't working, yeah? And he, well, yeah, all right, okay. I said, well, give us a multimeter, and give us 10-15 minutes, and just, you know, leave us for a minute to work it out. And anyway, oh well, there's a circuit diagram there, really complicated, and you know, there's the thing there. I said, yeah, well, I've been you know, looking at it for the past 10 minutes whilst we've been talking, so I think I know what's going on. So okay, anyway, I persuaded him to go out of the office. Right, okay, let's get this thing. Right, have a look at it. And I decided, right, I'll go for the amplifier, because that was relatively straightforward to fix. You know, a filter, if anything's wrong with a filter, it could be any component, and working out what's going where is really difficult. And amplifiers, you know, it's either going to work or not. So I, right, down there, come back in 5 minutes, like 10 minutes later. Right, okay, it's this, changed that component there, that component there, that component there. I think there was maybe 3, 4, 5 components, something like that, or that were wrong, or had gone faulty or wrong value, whatever.
And was this as part of your sort of introduction and job interview then, Geoff, or was this
yeah,
after
yeah,
you?
this was the job.
Yeah, okay, this was a baptism of fire then.
Job interview. So
you obviously got the job.
Well, yeah, basically, you know, they took those things and, you know, took out the girls outside who were making the boards up, changed, he says, change that component, that component, that component. She did, put it on the test and said, okay, let's run it. Run straight through the test. Well, I got the job.
Were you later involved in the design of any of this stuff, or was that for later?
Not at B&W. I did, when after a year or so, they moved us out of Stenning down to B&W's Meadow Road facility, which was the original main factory. And I was a little bit more involved in general test and measurement stuff down there. So I met Des Fisher at the time, who was doing some of the bits and pieces. So that was my first time to actually see and, you know, real measurements being done on an ongoing basis. This would have been moved down to probably middle to late 86, something like that, I think. Something like that, because it was after that that I moved to
and there it is, one hell of a big company at the time.
Yes.
I was
Is that
looking.
Downley Road site?
I believe it is. It was certainly one hell of a big site.
This is it was a different site when I was actually working there. I think you've shown the picture of the Downley Road site. They downsized.
Oh right, okay. My mistake. I humbly acknowledge.
Goodman's were one of those companies that in the 70s and 80s there were a lot of UK loudspeaker companies all gathered around a certain area in North London. There was Goodman's, there was Tannoy, there was Kef, there Rank had another one, Thorn had a separate one, and there was it was the Harman plant, who were called, it was ELAC, that's it, they were called.
ELAC, yeah.
And they were all in the same sort of area. And around about that time in the 70s, they all split. Town were going up north to just outside Glasgow, Coatbridge. ELAC going down to Bridgend in Wales, Kef going down south to Maidstone, and Goodman's going down to Havant. So the loudspeaker industry, you know, in the 50s, 60s were all very centrally located, and then they all just went all over the place. So it must have been hell for the people who were supplying the industry at that time, because they would, you know, they would have had a small patch to do, and then suddenly they had to go hundreds of miles.
One thinks of the move of Leek to Yorkshire to merge with Wharfdale when Rank bought them. Yeah, not the most successful of business moves. But just looking at Goodman's, then they've got this enormous diversity of drive units. They made TV speakers, didn't they, and PA and just about everything, as well as a well-established hi-fi range. Yeah, that must have been quite an apprenticeship.
Yeah, I sort of think of my time at Goodman's as my second apprenticeship. I know I'd actually been working with Brian before, but it was when I was actually at Goodman's that I got access to the AES library there, and got the chance to go through all of the journals from the mid-70s upwards. Sister company Morden Short had another set of journals which were 80s onwards, which I've now ended up with. And the guy who was at Morden Short ended up with the Goodman's one. Nowadays, of course, everything's online and available online, which makes access a lot easier. But it's still, I find it still easier to read an actual printed paper rather than electronically and online. Maybe I'm just old-fashioned, but
much easier to search the e-library, I would say. But yeah, take the point.
Absolutely. But if you want,
as I say, at Goodman's, you've got this incredibly vertically integrated industry, but I guess you would be testing on stuff that looked like this.
When I first got there, yes, they had one. When I arrived, they had one HP 3561A, and there was an HP computer, and that was it. And then it was, you know, you've got in the background there looks like a 2305 mechanical analyzer and stuff. Looks like a gating system there, so it's probably a 2010 in the back and a 260 6 mic preamplifier.
The idea being to provide a windowed measurement, with a tone burst. I don't want to dwell too much on that, but again, it was your background in how the testing was done at that time, very, very much so. And of course, presumably you moved on to other types of testing fairly quickly.
Yes, the test equipment at the time, the 2010 and stuff, was way past its sell-by date. It was unreliable, it was breaking down, and it just wasn't able to do the job. And you couldn't do it reliably. You couldn't print out any results in a format that you could transmit to anybody else, and you certainly couldn't do any sort of analysis on it, or pull together the results in any sort of sensible way. In fact, the curves and stuff that you get, you wanted a smooth curve where you just put your hand literally on the pen and just stopped it moving a little bit, and it would stop it jiggling around. It was an old trick, and some people did it. But the 2010 eventually went down and wasn't able to be fixed, and got to the necessary standards. So brought in an Audio Precision System 1 and Melissa, which those were the first proper measurement systems, I would say, that I got involved with. There was also an Autophon P400, which was not bad, but was painstaking to program, and it would literally have to follow the curve. And you had this EEPROM cartridge that you plugged into the front of it, and you could literally take a reference curve off of it, and then you had to offset the curve up and down, which was great for electronics, which was stable. But with speakers and the test and measurement systems at the time, the enclosures were all over the place. So you just a typical test box for a speaker would have peaks and dips of 20, 25, sometimes 30 dB in it.
Oh my goodness.
Trying to put a limit curve around that safely was notorious. And try as I might, it was something that defeated me at the time. I could get it a little bit better. You could EQ out the bottom end a little bit using a cardioid mic and stuff, but overcoming the fundamental problems was something that defeated me at the time.
And was all this presumably was by now in an anechoic chamber?
Yes, they eventually,
measurements, obviously the low frequency stuff where you couldn't use Melissa.
So the only way of doing it was to do the measurements in the anechoic chamber. They put in a big anechoic chamber using some wedges that they'd taken out of a chamber that had come from Downley Road, and previously had come from a chamber up in Wembley. So God knows how old some of these fiberglass wedges were, and they certainly looked it. And but this, this was a typical big chamber. It was about 7 meters by 5 meters by 4.5, 5 meters high, something like that. Enormous great thing with wedges which are 5.5, getting on for 6 feet long. So the reasonable sizing in there, but it had great big RSJs round the outside of the thing, suspending a floppy mesh floor, which had a light gauze cover put over it, cloth cover, open cloth cover, to try to stop screws and stuff dropping through, because if they did, they dropped through onto the floor, 6 or 8 feet down. There was no way of getting anything back up from there.
Good time to be in an anechoic chamber when you swore loudly.
Well, yeah, but you didn't want to do that in the goodness chamber, because when they fitted the chamber, and I won't say who fitted it out, they had a double door in it in order to give the isolation. great idea. Outer door, inner door. And there was a push button on the inner door. So you push the inner door and it pushed the button on the outer door to open it. Great. Trouble is that the idiots hung the outer door the wrong way around, so that you push the button and it pushed onto the hinge of the outer door. So anyone who was ever trapped in the chamber was never, ever going to get out.
I won't ask if you ever got stuck in there, but it doesn't sound good.
No, the rule was that in order to work in this chamber, you had to have two people on duty at all times, one working inside the chamber and another one outside. Needless to say, people didn't do that, but they just didn't bother closing the outer door at all, which sort of defeated the point of the noise isolation.
What about the LF response? Was it?
That was horrible. That was horrible too. The worst problem was that whoever done the calculation done a brilliant job on making sure that if you were trapped in this chamber, you had plenty of ventilation, and they had so many changes in air, etc., etc. But they've completely forgotten that a ventilation system like that is basically a nice big steel pipe. Well, it's like an organ pipe going at 15 hertz, producing about 95 dB, and boom, boom, kicking away at low frequencies. That was where the main harmonics 15 hertz, but there was lower frequencies as well. And no, it was no. I don't know how much money it cost them, but it wasn't worth it.
But nevertheless, you were successful, having done your sort of second apprenticeship there. You engaged on the Goodman's Imagio, which yes. I hadn't been aware of at all. I wasn't even aware that there was an inductively coupled tweeter. Quite an interesting technology, even if
that was the concept came from Dr. Boaz Elieli, an Israeli chap who used to work for Celestion. And he came up with the idea. He was the designer behind the SL6, I believe, back in the early 80s, which is the one which had a copper dome. And
well, yeah.
That apparently the story I heard was that the copper dome, that he found out and he learned that the tweeters that had a copper dome that was complete copper dome were slightly more sensitive than they should have been according to theory. And he noticed that, and he noticed that there was a difference in the impedance at the high frequencies, because the copper dome, the circulating current around the rim of it coupled into the magnetic field and the voice coil and gave extra output, and that became the genesis of the ICT. And Goodman's at one time, and later Harman, who produced their own version with slightly different mechanical arrangements, sold shed loads of them into I think it was the Fiestas and the Sierras and of the time. They were selling them by the bucket load, and they've got certain advantages to them, in the sense that although you had a tweeter in there and it was coaxial, obviously, you didn't have the mechanical connection, you didn't have the electrical failure modes of a conventional tweeter either, and they were pretty well bulletproof, but they needed some design finesse that was really quite difficult to do. And the very first version, which you can see there, was only so-so in the way that it worked. It wasn't very robust, and you can see the chassis there aren't very strong, and it was one of my jobs to take it over. You can see the picture in the middle has got the Mark 1 version. The Mark 2s are in the Imagio range to the right, where the chassis has been reduced down in size and it was heavily strengthened up. And I changed the alignment of the voice coil and stuff in order to be able to get the thing to integrate better.
Was the inductance between the two part of the crossover? Presumably it was.
Yeah, the inductance of the voice coil was actually what you needed to drive the inductively coupled dome.
Of course,
so,
yeah.
Whereas with a conventional bass mid-range driver, inductance is your enemy, because it just rolls off the high frequencies. With an ICT, you need the inductance in order to be able to give the coupling to drive it effectively. But at the same time, you've got to trade that extra inductance and the driving force that you get from it at the high frequencies with controlling the frequency response of the cone. So there's a real old balance, and this is a time when FEA wasn't really available. They were just about starting to do some analysis on it, and in theory we had one there, but it was out to a student, and I didn't have access to it. There was a laser available for a short period of time. I actually used that for doing some measurements on a cone.
Just one question about the Imagio though. I mean, presumably not only have you got that what a friend of mine would rather vulgarly call a bugger's muddle of compromises, you presumably also got to handle the variation in coupling as the woofer moved back and forth, over fairly large X max.
Yes, absolutely.
Quite a fruitful source of intermodulation distortion, I would have thought, if not carefully addressed.
I don't know. Intermodulation distortion is a bit of a misnomer. Lots of people have tried to track down pure intermod distortion and said that you get intermod distortion and Doppler distortion, but it's pretty rare. The problems that plague loudspeakers tend to be more to do with non-linearities and changes in characteristics with displacement, which is something that Wolfgang, of course, has done a lot of work on. And so all of these things, since the 70s, 80s, when I first got involved in it, we've got a much stronger background in both theoretical and practical understanding of loudspeakers. And today, of course, one of the companies that's making the biggest inroads in that respect is Purify. Who've got some really good ideas and some really interesting ideas. Not that they're the only way of going.
Interesting stuff. I mean, you mentioned the perhaps if amplitude modulation distortion wasn't an issue. I think you had some issues. You touched on measuring the cone.
Yeah.
What was that about?
Well, you've probably heard the story of the LS35A that when they first got the thing together, if it wasn't the LS35A, it was certainly one of the BBC speakers had a quacky sound in the mid-range, and it was using was one of the Beckstream cones. And I had a similar thing with the Imagios. This is a few years later, and I'd remembered about the thing, but I was wanting to know a little bit more about it. The BBC 35A, the bass driver, which is, I forget the number, of the drive, doesn't matter, had a very heavy,
B110, B110.
110, that's it. Had a very heavily damped cone, but I wanted to go a little bit further with the thing. So I, this is years and years ago, back in the 90s sort of thing, decided, well, if it's the cone, then I don't need to measure the whole cone. You know, I knew that the response wasn't bad, but it was misbehaving itself, and I could hear it in the sound. It was sounding horrible. But it couldn't be the voice coil and the motor unit, etc. So we had material. So I thought, well, what if I just take a cantilever, basically take a small strip, and I made one that was about 100 millimeters long, maybe 5 millimeters wide, out of a sheet of basic plastic Vextrine, and I made up a motor unit, because the advantage of the vertically integrated company was that, you know, if you wanted to make a drive unit, well, I just went to stores and got the bits out that I needed, whacked them together in the combination I needed, and away I went. So I made up a motor unit, and I put a double spider on it, and put a cork or something in the top of the voice coil, so, and to give me a platform, and you know, a couple of bolts and nuts sort of thing, so I could, you know, clamp this cantilever down, and then put it onto Melissa, send the signal through. The Melissa works on the basis that it's putting out a pseudo random noise source, which it cross correlates the signal it's putting out with what it's receiving back to generate an impulse response. Did that, and I used a laser to look at the results. And as soon as I did that, you could see that this cantilever was ringing for about half a second. Yeah. No wonder it sounded horrible. The whole cone was just carrying on forever and a day. Anything over 20 milliseconds is bad news, but half a second, forget it. And I just ended up putting a thin layer of damping over the back of it, dead within 10 milliseconds, 5 milliseconds, something like that. And that's what I ended up on the back of the cone. Put it on, listen to it. Great. It took maybe half a dB off because there was a little bit more mass, but that was nothing. But it sorted the sound out completely. So
and that's the result in these actual commercial Imagios then.
Yes. Yeah.
Which, apologies to whoever listed those on one of the forums I stole the photograph of. I hope that's a plug, but it did say they sounded great.
Yeah, they got some pretty good reviews at the time. Unfortunately, it was right at the end when Goodman's, like so many factories at the time, they were run by people who didn't really understand what they were doing, in my humble opinion, and they decided to put all their money instead into factories in Poland and Mexico to build speakers for the car industry at loss-making prices. So the hi-fi bit, which I was working for, which was making a modest profit, but it was covering my costs and the cost of the sales and the production and everything else. Making a return, they shut that down, kicked out Warren Short, which again was making a modest profit. Put all their eggs in one basket and lost a few million over the next few years, and bye company.
Yeah, sad end to a very famous name, and I'm sure a fruitful bar discussion afterwards for for engineering managers.
Unfortunately, not the first time that's happened.
No, indeed. So you were out of Goodman's then. This would be what, the early noughties, something like that.
And yeah, in 1999, early 1999.
Turn of the century then. And what did you do after that, Geoff? Tell us about that.
Well, I went briefly to Wharfdale, which got me up to China, which is where I met my wife, and then back to the UK. And that job went down. And I then moved sideways into the mobile phone area for, first of all, Ericsson, working on the Hedvig phone as a consultant out in RTP, Research Triangle Park, in North Carolina for about 6 months. And that's on the top left of that image that you can see there. I was working on the earpiece in particular and setting up a measurement system to analyze literally hundreds of thousands of those pieces. You know, hundreds of thousands was the numbers that they were making, that were supposed to be making it.
So a real baptism of fire in statistical process control and
absolutely, yes.
Yeah.
I'm trying to work out why this damn thing was varying and what to do about it, and you know, how to analyze masses of data so that you could actually, you know, pick the bones out in a sensible way. And that was where I pulled together some of my beginnings of the techniques that I later put to good purpose in analysing speakers and stuff, and then went into the books, etc., to say to people, you know, how you can actually look at stuff and actually work out how the facts behind what's happening.
Mm-hmm. And how were Motorola testing? I mean, presumably artificial ears, but other facilities?
Well, the case there was that they brought me in. Again, it was Basingstoke, where I was based in the UK, and they brought me in as a full-time Motorola to put together a new test lab for Tetra phones. And you can just see some of the examples of the Tetra phones down below there. And there was a range of about 5 or 6 different plants throughout the world. So there was one in Ireland, one in Germany, one in Italy, another one in Penang. There was one in Florida and another one in, I think it was Schaumburg in the States. And each of them had their own ideas as to what was going on and how they were all working. And there was a problem at the time that the earpieces of one were louder when they were being heard on one of the other systems and vice versa. So the interoperability of the Tetra system, which was a digital system, was all over the place. The problem was that because they were all independent sections, there was no one area to keep control of the whole thing. So one of my jobs was to actually test all of them, put together a test lab in the UK, which would test all of the different software builds and bring them all together, test them all unit to unit, transmission to transmission, receive to receive. So you had earpieces, you had microphones, you had the handsets themselves, and you had software builds, which would typically once or twice a week they would come out. So there was a lot of different combinations had to be checked. The basic radios, each of which have got their own bits there, and all of the accessories, and they all had to be tested for interactions between all of them to make sure that we ironed out all those sort of problems. So I had to first of all build the equipment and the software and everything else that will pull all that together, and then start to do all the testing and get it ramped up and get a cadence going, which I then passed on to other people after having got the damn thing done. I tested quite enough.
And do I recall you saying when we were chatting just beforehand about that they actually use an anechoic chamber extraordinarily for mobile phones or radios? Yes,
absolutely. The standards for the mobile phone industry, defined that an anechoic chamber had to be used. It had to be a clear field of X amount around of space around the particular microphones and receiving ports. So I ended up putting in the chamber, which I think was about 7.5, 8 meters long by about 5 meters or 5.5 meters by 4 meters, something like that. Massive great thing. And it had a couple of big double doors that you could go in, and I ended up putting 2 splitters down on the left and the right, so that could isolate each half off independently. So there was a HATS set up on one HATS head and torso simulator, and another HATS head and torso simulator on the on the left side, both of which were fed out to their own individual audio precisions. I think they were system 2700s.
All that space for testing to the small transducers, because the standards required it. Extraordinary.
Yeah, and using Rohde-Schwarz RF modulators, etc., into the digital system. So they had, within the basic site factory, there was a complete Tetra radio system in effect.
The thing that stands out to me in that discussion is just the extraordinary size of the chamber required, given that you were working with mobile phones. It's not my direct area, of course, but certainly a startling statistic. You moved on from Motorola after a handful of years, probably sick of the sight of millions of phones, I guess. What happened thereafter?
That was they like so many big companies, they get to a point you've done basically the bit of the job that you were employed to do. So then they decide that the focus shifts, and you're made redundant, move on to something else.
And that something else was a move back into probably your preferred territory of the audio, the hi-fi industry.
Yeah, exactly, more audio. And then it was a case of right, okay, let's get on and do it, and work on drive unit design, primarily drive unit design, and crossover integration. Also set up the engineering lab, and brought in Clipple and Loudsoft, and started the console FEA analysis. I brought across FEMM, which is magnetic analysis, which I've been using for a good few years anyway. So the monitor audio, there was a lot of work that I did there, plus designing the GS range, the drivers for GS range, the platinum ones, Apex, ceiling speakers, in-wall speakers, etc., etc.
It sounds like you had a pretty free hand to sort of steer the ship, as it were. Was it Dean Hartley? Was it from Fame?
Dean Hartley was the technical director. He was based up north. And he and Charles Minnitt were responsible for all the visual stuff. So thank God I didn't get involved in that. Visuals have never been my strength, and I was quite happy to leave that side of the mechanical design and the visual side to somebody else. But I ended up, stitching it all together and making sure that everything worked. Because at the end of the day, no matter how pretty a speaker is, if the damn thing doesn't sound right or doesn't actually give the sound that it needs to give, then it's a no-go. It can be as pretty as you like, but if it doesn't work well enough and doesn't actually sound good, what's the point?
Absolutely. Were you given a brief, as it were, in terms of design, Geoff, or were you tell us how that happened? What was the genesis of these products?
Generally, the brief would be, the overall sensitivity, ideally the overall frequency range, and obviously you were then given an overall number of drive units of such and such a size. There'd be a certain amount of interplay in there. And like on, say, the Platinum ones, the original version, the thought was to make a new version of the metal dome tweeter, and I'd been working on those, and they were good, but they just weren't good enough. I'd done if I say myself, a damn good tweeter for the GS range, building on everything I'd learned over the years. But we ended up using a ribbon tweeter, which was just head and shoulders over what the metal dome could do. And so it's a case of you try to make a step forward in everything that you do and improve at least a little bit on what you've done in the past. So
the diaphragm designs look quite interesting on those. Was there anything particular about those that you wanted to?
They make a lot about the ripples in the cone, etc., which does make a certain amount of sense. And if you do, and I did some basic FEA analysis on the thing by putting, as you know, if you've got a car bonnet, very rarely, if ever, do you have a completely flat bonnet, because the metal just flops. Instead, you make it with ridges and shapes in it, because a shape is inherently stronger. And so the whole theory behind it was that by putting some shape in the thing, you strengthen the whole cone, diaphragm up, so you make it more rigid and less prone to break up, or make the breakup more controllable.
Were these all metal domes? Some of them certainly look like metal, but
yes, yeah. Montreal here, they're all metal dome.
So quite a challenge to keep the breakup of the woofer, I would have thought, under control.
No, once you've got the main trick is making sure that you get the thing to break up consistently. Once you've got it consistent, then you can deal with it. Mm-hmm. And it was at Montreal that I was able to bring together all the work that I'd done in the past, and so doing analysis and statistical analysis with the clipper, which could export all the data, and so you'd end up with a spreadsheet which basically summarized the performance of a batch of, say, 10 or 20 drive units, so you can then measure all of the large scale parameters, at least the key ones, for displacement, any distortion and frequency response, etc. And then you pull out the minimum, maximum, average and standard deviation of those responses with respect to frequency. And by doing that, you can then see immediately if you've got, say, a breakup of a cone, if all the cones are all breaking up together at the same point, fine. You can put in a crossover in order to be able to control it and pull it out, sort it out, no problem at all. If, on the other hand, it's spread and the distribution is uneven, you've got no choice. You know, one's up here and the other one's down there. They're going at different frequencies, etc. Right, at that point, you go back to the manufacturer and you figure out what's going wrong with the process, because there's always something happened with the process. And so it's a matter of, you know, using your ounce, using your brain to say, well, what's actually going wrong at the moment?
Interesting, yeah.
Underlying problem, then we sort out the underlying problem. Once you've sorted the underlying problem out, then you know what to fix, and then you can put the band-aid on if you need later. Usually you've done it right.
I'm mindful of time, but I'd just love to ask one thing. If you have a strong in-band resonance from breakup of the drive unit and you notch it out with the crossover, is there not a risk that you'll get that resonance singing from harmonics that are created within the motor, even though the crossover notches them out?
No, not if you've balanced it up properly. You've got to be careful, and you've got to underdo it rather than overdo it. But you normally get to a point where if you've got a resonance and you've taken it back down from say a 10 dB peak, and you bring it down to a 1 dB peak. Once you brought it down to that 1 dB peak, it's something that I learned years ago, that once you get a frequency response that's near as damn flat, they get to a point that they just integrate themselves flat and they just drops out. Because there isn't enough energy left to start the resonance going, at which point it doesn't get going. And well, if it's not going, resonating, there's no problem.
Okay, sounds good, yeah. I'm sure we can come back to that in the chat room, because it's been an interesting topic, certainly for me. Mindful of time, because we could talk for hours like this. I certainly could. After Monitor, at the turn of the teens, 2010 or so, yeah. You were back in consulting again.
Yes, yeah, that's right. Initially I went out to China, and then I came back to the UK and did some work along with Brian on the Aspara speakers. And that was about the time that I started to pull together some ideas on the book. I was getting more involved with the AES a little bit, which I'd been a member of for many years, but hadn't really got active on it. And I started getting involved at the SC0403, and there was lots of people, complaining and commenting of how unstable loudspeaker measurements were, and there was no real good choice other than an anechoic chamber, and what could be done about it. And several people put forward ideas toward that. And then I had a company in the UK, Hill Acoustics, came up with a need to measure loudspeaker drivers again. And I sat down and said, look, I've got to sort this out. This had been, it had been a perennial thorn in my side for many, many, many years. There just wasn't a good way of doing it. And I decided, right, I'm going to, solve this problem once and for all, and get the damn thing done. And I was you know, perhaps
it sounds like a number of strands of your career came together all in one sort of perfect storm at that point. You've got the statistical QA from your mobile phone days, your obviously traditional speaker measurement, we'll call it loosely that, and then the need for something different, both coming from the standards group and from NEAT. So yeah, the genesis of the TTC, which we'll move on to now, I think, is available just to for everybody's benefit on audioxpress.com, and I believe both the parts are freely available for download there. So if anybody wants to visit those, I'm sure we can put that in the chat afterwards as well, or make that available somewhere. But if you Google Geoff Hill Audioxpress TTC, the first page you come to more or less is a list of these 2 articles.
Yeah.
So yeah, there's lots of detail there, but tell us a bit more about the TTC then, Geoff, and how it solves the problems for those who aren't familiar with it.
As you can see by the shape in the picture there, unlike a conventional box, it's not a box. Boxes, well, they sound boxy. And the reason is that you've got parallel surfaces, and if you've got a cubic shape, then you've got 3 parallel sets of surfaces, and so sound goes backwards and forwards and builds up standing waves, and you end up with horrible peaks and dips, and you can end up with literally, as I did years ago, 25-30 dB peaks and dips in your responses. And unfortunately, a lot of manufacturers to this day still say, oh, well, what can we do? Well, we're making some speakers, we've got some boxes, we'll stick a microphone in the box, and run, and you know the box will handle the drive in it already. We'll just turn it up the other way and measure it. Oh God, please don't. Whatever you do, please, please, please don't do that. It's a disaster. It's just not going to work. It's guaranteed to go wrong. So the first thing I did was say, right, let's design it so that it doesn't have any parallel surfaces. Let's get as far away from that as possible. Hence the design. That's one of the key points. I don't go into detail of the design in the articles or whatever, but the principles are out there, and they're straightforward. They're straightforward enough. But what it does mean is that these things are accurate and they're consistent. It's consistency that to me is the most important thing. You can see on that curve there, there's on the screen, there's 3 graphs or 4 graphs there. You've got the light yellow curve of the drive unit. You've got behind that in the light blue the response of the speaker drive unit in the chamber raw, and then you've got a almost dead straight line, which is the correction curve for the low frequencies, with a little bit of a ripple in there for the sub 1K area, which is the correction curve for that particular chamber. They get a slight difference with the correction curve on each chamber size, yeah, sure. But they give you the capability of measuring loudspeaker drivers, microphones and stuff like that, down to, well, effectively DC, which is far better than, you know, an anechoic chamber will give you, in a much smaller physical space. And
absolutely, yes. And presumably you are loading the drive unit here to some extent, but in a known and controlled way.
Exactly. And the thing is that in the case of that there, it's essential to make sure that the chamber that you're using to measure any particular drive unit is big enough that it's not shifting the drive unit's parameters more than maybe say 5% on the resonance. That's fairly safe factor. If it is, then you just need a bigger chamber, and away you go. So, you know, that's the case. You can see there I'm holding a 350, which has got about 20 odd litres internally, which is fine for that size drive unit. And but if you need it less, then you go for a bigger chamber. You know, that will be fine for a 4-inch and downwards. But bigger chambers, obviously, for bigger drive units.
Yes, indeed, and you've also used these for microphone testing, I believe, and they're also accepted in some of the standards. Now, you've been so successful with this that actually, finally, the world is coming to its senses, shall we say?
Yeah, yes, absolutely. They're embedded in 602, 68, 21, and 22 as, you know, an alternative method for making comparative measurements other than an anechoic chamber, which to me is, you know, good news that we've got an actual alternative that's stable, has been proven to be worked. You know, I've used them within the AES 73ID to provide the reference quality measurements, and if you go into there, you can see the capability that you can get on the measurements, where you come from. Typically, before, people were arguing, well, you can't measure loudspeakers to better than plus or minus, you know, 3 dB, you know, and you're lucky if you can do that. Whereas in practice, a TTC will reliably measure to plus or minus 0.3 of a dB or better.
And freely available for download from the e-library for anybody who wants to look at that. Just mindful of the time, Geoff. Come on to the present, as it were. You're still working not only on the TTC but on other speaker designs. Yes. And I know this was one you were keen to show.
Yeah, that's one of the jobs that I did for a company out in India, Anna Logan, and it's a very high sensitivity loudspeaker, 98 dB for 1 watt, home cinema type system. I say myself, it's pretty damn good. And they're building on, you know, all my experience over the many years of actually getting high efficiency speakers and getting them so that they're, you know, completely neutral, as close as I could get to being totally neutral and totally open. The only thing that they're slightly lacking on is getting down to, say, you know, the 5, 10, 20 hertz region. Otherwise, they're fine. But that's something that I'd like to, you know, work with, you know, people like yourself on the bass type systems. You know, there's some work there, and you know, one of my major things is to try to pass on some of the information that I've built up over the years, which is why I wrote the book, and I started writing my book similar time that I started writing the test chamber, and working on the test chambers. And so that was a matter of trying to pass forward some of the knowledge and experience that I built up over the many years to other people. But at the same time, I also want to use my skills and work with other people so that I can help to maybe work alongside younger engineers and pass on some of my skills and knowledge that way. So, you know, I'm keen to work alongside people and, you know, keep active and keep busy and, you know, contribute to society as a whole.
And what better way than to encapsulate all your knowledge in a book and allow people to, you know, to benefit from that. I'm sure that's something a lot of people would agree with you. One of the things, again, that we talk about sometimes in the AES committees is the sort of scope of education that has to be covered these days, and the subject doesn't get any less deep. It gets broader and broader and broader as we bring in more and more IT related disciplines, digital, FE, all of those things. But there is still the need for the knowledge in the core areas of drive unit design and so on.
Absolutely, and one of the things that I wanted in that book was to bring drive unit design back up to the, you know, 2015 when it was when I first started writing it. And it 2015 through, it was published in 2018, 19, right at the end of 18, was to get design so that people now can download the software, they can run it on the PC. Yes, I'm afraid it is PC based rather than Macs. In theory, you can use various tools, etc. The reason is that I'm afraid I'm a PC guy, and although I've used Macs, etc., most of the sorts of software that I've used over the years have run on a PC, and it's just easier to just run with what you've got. So I apologize to anyone who doesn't like that, but you know, I've got to start with that. And I've just tried to, you know, develop it from the basics and to say, right, you know, this is how a loudspeaker works. All the theory is being published anyway, so I don't go a lot into the theory other than the real basics that are necessary. And then, right, how do you get to design? Because the problem with the academic way that I think loudspeakers is taught is that it's all about the theoretical analysis and how it works, rather than, as an engineer, you don't want to know how it works. You already know that. What, as an engineer, you always want to do is you have to ask a slightly different question. And the question, in my view, is nearly always, I want to achieve that. How do I achieve that?
Mm-hmm.
And it's defining that is the key. And it doesn't matter whether you're designing a loudspeaker, you're designing a house, a bridge, a car, anything. You're nearly always having to answer the question, how do I design, how do I go from where I am now to that? Those are the steps, you know, and I try to go through some of those steps in the book. One of the things that I did, which I've had some good feedback on it from people who've read on the book and read it and worked it through, is that I'd go through the steps, and then in the back there's, for each of the main programs, there are a series of tutorials that will take you through each of the individual programs that I use to analyze some of the individual tasks to do the job, so that hopefully it can then act as a primer to somebody who hasn't got an engineer like myself sitting on their shoulder to ask the questions of. And you know, that way I can pass on some of the information that I built up over the years to other people in the future.
Indeed, you mentioned paying back and paying forward.
Paying forward, exactly. We can't pay back. None of us can. So let's pay forward
and train the next generation of engineers. Yeah. Geoff, I think that's a wonderful point at which to leave the formal talks, informal as it has been, and move to the chat room. And Well, I'm sure, well, I know there are already some questions and answers, and I'm sure there'll be a number more. Geoff, thank you so much for taking your time this evening. We've overrun a little bit, but I think it's been a fascinating discussion. I could just, for one, carry on all evening. I hope everybody's enjoyed it out there as much as I have, and we'll reconvene in the chat room. I don't know whether applause works on Zoom. It probably doesn't, but I know everybody out there will want to join me in sharing their appreciation very much indeed.
On the chat, so okay,
that's great. Thank you, Geoff, very much indeed.
Okay, all right. Hope to see you all shortly.
And we'll see everybody hopefully on the other side. I believe Sue is putting, there it is, the link up for the chat room where everybody can join in interactively. I'm going to stop sharing here and duck out of this, and everybody else hopefully likewise will follow us. If you don't join us in the chat room, thanks for attending tonight.
So if you can directly send it to me, because I'm not sure where it went.
Okay, I will do that. Thank you again, everybody. Thank you, Geoff. See you on the other side of the chat.
Okay, thank you. Cheers.